This video I'm going to look at the problem number 6, the final problem in our practice final. This problem goes like this, so that's my noisy neighbor there. Number 6 says, are female students more likely than male students to have completed the math practice test? And this is test preparation completed. So in there we can see the word likely, which unfortunately it's not always the case, but it's very often the case that if you see the word likely, it means that this is a problem about categorical variables. We'll look at our two key values to make sure that this is indeed the case, but it looks pretty much that way. So we have our first key value, I guess, is the number of female students who have completed the preparation test, and we want to compare that, of course, to the number of male students who have completed the preparation test. Basically, we're saying that the number of students who are female students amongst those who have completed the preparation test, there's more female in there, is what I'm trying to say. So this, if we look closely at this, we'll see that actually in there we can find only categories, because female, male students, those are categories, and so is test preparation completed, because the other option is not completed. So this means that this indeed is a chi-square test sort of problem. And what we need to do is figure out our variables. My first categorical variable we could label sex. In there I'll have two categories. I'll have female and then I'll have male students. And because female students, this phrase actually comes before the word likely. This means that this categorical variable here, sex, is the independent variable. So I'm going to star my little label here. And we have also second categorical variable that I could call preparation test, and in there we'll have two categories as well, whether I completed or none. This is what appears actually in my data sheet. So we now need to turn our initial claim into a claim about conditional probabilities. So this is going to be my HA. And I suggest you probably should start with the independent claim, because we know that's always after the bar. So it says, are female students more likely? So the probability we're after as the category female after the bar. And we're interested in female students who have completed the math practice test. So that's C. So, and we're saying that this probability is going to be higher than, again, we could use the independent category first. So it's going to be the probability, given that I am a male, that I have also completed the preparation test. And once we have our HA, it's easy enough to come up with the null, because we simply replace the sign in there by an equal sign, and that is our null hypothesis. So that's the conceptual part. Now we need to turn to the Excel calculation sheet. So now I'm in the Excel document where the data is to be found. So this, because this is a chi-square test, there's no need to reorder the data. Actually, I can just copy. So I'm going to click on the first cell and go all the way down. I'm going to maintain shift here, and I'm clicking to make a selection of my entire column here. And I'm going to, again, paste special as values. So this here is my first variable, and my second variable is test preparation. So I want to select that as well. And again, there is no reordering that's needed, because we're just going to count values as part of the table here. So I'm going to build that table. It's going to be here female like this, and then male here. And I think I remember that I have to do that, otherwise it turns it into a different sign. So this will be test preparation completed, and this will be not completed. There you go, something like that. I have my total here, my total there. I can resize a little bit if I want to see my data more, my info here a little better. And then what I'm gonna use is our count ifs. So I'm gonna say I want to count from A2 to the end of this one. And here I'm gonna say I want to count, because I'm looking right now for female, but it has to be written exactly the same way as it is written in my data here. So I'm looking for female in the first one, and I'm looking for completed in my second column. So I'm gonna do the same thing for my second column, except that now I'm looking for completed, and again it has to be the same way. So again, count ifs, I specify where I'm looking for the stuff I'm looking for, and then what I'm looking for exactly. Same here for the second column, and then the key thing to remember is that it has to be written exactly the same way as in as in the data here. Once I did one, I can copy. I'm going to paste this here, and then I'm still looking for people who have completed, but this time I'm looking for male students. So I'm going to go like this, and then I'm going to paste again here. This time I'm looking for female, but I'm looking here for none. So I'm going to replace this with none. And this last one here, I'm looking for male and for people who did not complete the test. And this here is those numbers. So here I'm gonna compute my marginal totals. So I'm doing this using the sum. Once I did one, I can do the other one like this. It goes like this. And I'm going to copy this one, and this one here is supposed to correspond to the sum of the entire table here. And you may want to make sure that the marginal column totals, so these two guys here, when they you add them up, you get to the grand total, and the same goes for the marginal row totals. So they should add up to the grand total. So everything looks very fine here. So this is my observed table, and this is what I'm going to use to specify my conditional probabilities. So I'm looking for whether I'm more likely to have completed the test given that I'm a female student than if I'm a male student. So this is going to look like this, and then I'm going to try and find those two values. So this here, the probability of C given F is the cell count where C meets F, so it's this one. I'm just clicking on that cell, divided by the marginal total associated with F. In this case, it's a marginal row total, so I click here, and this is my first probability. I'm going to put the second one here. So this probability is the cell count where C meets M, so it's equal to this one, divided by the marginal row total, in this case corresponding to M. And this indeed is a smaller probability. Oops, so I can say that my hypothesis holds within the sample. So now what I would like to know is if I can generalize this to the population. So I'm going to copy this material here. I'm going to again paste a special as values, because I used formulas to do my totals, and they are not going to do well if I delete the numbers like I just did, but that I want to do that because now I want to create my expected cell counts, and these always are done the same way. It's the marginal column total times the marginal row total divided by the grand total. and this is never rounded up. So this one again, marginal column total times marginal row total divided by grand total. And there we go. It's always the same thing. Marginal column total times marginal row total divided by grand total. And for the last one, here like this. There you go. This is again my these are my expected cell counts. So this here looks fine because in order to get a p-value from the chi-square test, I need all of my cells in here in the expected table to be at least 5, and there's no issue here. So now I'm going to compute the chi-square test, which is I'm going to do, there's several chi-square options, but I want the chi-square test, and I'm going to then select the actual range, which is the inner part, not the totals, but only the inside of my observed table. And then I'm going to add the expected cells. This is my expected range, so it's again only the inside of my expected table. And there is my p-value. And in this case, my p-value is larger than the 0.05. And so this means that I cannot go on. I cannot generalize. So in this case, it is not the case that I can safely assume that my hypothesis also holds in the population. So it does not do, I cannot do that. So because I found that result, I have to stop here. And that's it for number 6.